Hello, good morning.
Good morning, AJ.
We are starting in the next few.
Morning, AJ.
Hey, good morning.
Hello, good morning, everyone. Thank you so much for making time to join us today, and thank you for honoring our invite. My name is Dennis Ndegwa, sales engineer at Amotech Africa, and we are excited and glad to host you today for this exclusive webinar. So we will invite you to, I want this webinar to be as interactive as possible. So if you have any questions, if you need any clarifications as we go through the webinar, kindly feel free to ask or seek clarification. You saw that it is a joint webinar between a few companies, Amotech Africa, EV Charger, and Advanced Mobility. So before we start, I'd like everyone to introduce themselves, the host for today. So we'll start with Amotech Africa. You'll introduce themselves and then we'll take it from there. Yeah. So I'll invite Jackson from Amotech.
Hi, everyone. My name is Jackson Mwema. I'm the head of sales in Amotech Africa. It's a privilege to be here, and for you who have joined us, want to thank you for your time, and looking forward to having an interactive moment and learning new things and how we can shape up the battery management market in Kenya and beyond. So without further ado, I'll present something about Amotech Africa and then hand over to the next partner that we have. So Amotech Africa is a test and measurement company. We deal with test and measurement for electrical, mechanical products and services, as well as we have a repair and calibration lab. We have a blueprint in 6 nations, that is in the Eastern Africa region, that is Kenya, Uganda, Tanzania, Ethiopia, DRC, Rwanda. And among the things we do, we have a number of things that we do, that is the services. On the next slide, we'll have something that shows what we do exactly as Amotech Africa. We have our main departments, that is the projects and services. We have product sales, where we deal with the specific products for specific customers. We have a training department as well that deals with equipping our well-able engineers with the knowledge and the know-how to be able to penetrate the market sector that we deal with and have the products and solutions that are needed in the market. We also have a repair and calibration lab that is ISO 17025 certified, and these are I would say it's something that we have been yearning for, and it's something that is expected to boost us in terms of the market penetration. So in terms of the markets that we operate in, that's the vertical market. We have the utilities, we have the oil and gas, we have the food and beverage, that is on the next slide. We have a number of education and research, manufacturing, renewable energy, military, automotive, and so on. So finally, I'd say the services that we offer, some of them being what we are going to go through today, that is battery testing. We do the site acceptance testing, that is in the services department. We do as well as cable fault location in terms of our service and so on. So that's a brief introduction of what Amotech does. And finally is the main thing, that's the repair and calibration lab, where in the picture we can be able to do electrical, pressure, temperature, and torque as well. That is the repair and also the calibration. Thank you very much. And so in terms of, yeah, thank you very much.
Thank you, Jackson. Alex will now introduce Advanced Mobility Center. Alex, can take us over.
Okay, good morning, everyone. My name is Alex Munene. I'm the fleet mobility expert at the Advanced Mobility Center. So we do 3 main things. If you see the next slide, that we focus on 3 main things mainly for the transport industry. The first thing is fleet management support. We help fleet operators to structure their businesses to be more cost effective. And then if you're dealing with vehicles, you have a problem to sort, which is drivers. So we offer advanced driver training, and we are NITA certified in this, from driver assessment, defensive driving, eco driving, 4x4 driving, and of late, we're also doing electric vehicle driving. So we help drivers transition from diesel buses to electric vehicles, which is a different technology. And the last thing we do is the mobility training, mainly technical training. So we've done 2 rounds of training already last year and early this year, technical training, and I'm seeing some of the participants in the webinar. And we are hoping to run probably another program mid this year around June. So we'll keep you posted on that. And moving to the next slide is just an illustration of some of the trainings that we've carried out. And looking at the focus of the webinar today is the technical training, where we did actual disassembly and reassembly of an electric vehicle, checking the different components. And this webinar is just a natural progression on that, because some of the participants from those training sessions would like to know how they can grow their career. And this partnership with Amotech Africa, EV Charger, and Midtronics provides a very good resource tool for them to know the kind of tools and equipment that they need to be able to grow in the e-mobility industry. So finally, we finish with our contacts on the next slide, so that if anyone is interested to get more information about our programs, our services, because our goal is to spread this gospel of e-mobility across the African continent, because we have a Pan-African vision, and we look forward to a very impactful engagement in the webinar. So thank you, and looking forward to the discussion.
Thank you, Alex, for that brief and informative introduction. Next, John, EV Charger.
Yeah, good morning, everyone. My name is John Singo. I'm the Chief Revenue Officer of EV Charger. EV Charger supplies, installs, operates, and maintains four-wheeler electric car charging infrastructure. These are some of the public chargers that we have. We have Two Rivers Mall, Waterfront in Karen, City Mall in Nyali, Sportman's Arms in Nanyuki, Westside Mall in Nakuru, Mega City Mall in Kisumu, and the latest one is at AdLife in Kilimani. Next slide, please. We have also put up chargers for corporates, for fleets, and also for homeowners. So we've worked with the Standard Media Group, Kenya Airways, NCBA Bank, and if you can actually have a look at the final one, the final picture, that is a home installation that we did. And for those who are keen, you'll actually notice that that car is actually a plug-in hybrid. So we think that that is also something that will really be a common occurrence now going forward. Next slide, please. We do have an app that I encourage you to go and download it, either on Apple Play Store or Google Play Store. Just search for EV Charger. Next slide, please. Those are, you can reach me at email or that number there. Pleasure to be here. Glad to be a part of the pioneers in this new industry. And happy learning to everyone. Thank you very much.
Thank you, John, and thank you to everyone who introduced their companies. We'll share the contact details after the webinar so that you can be able to reach each and everyone person who will be presented today. Now we go on to our host for today, AJ from Metronics. And even as he starts, I'd like to reiterate, we want this to be an interactive webinar. So if you have any questions, if you need any clarifications, feel free to just raise your hand or type your question in the chat box. Chat box is open to all. So without much further ado, AJ, you can take it over.
Yes, thank you for the introduction, Dennis, and good morning, or what time in the day it is at your place, to all of you. I'm very glad that we are invited to give some information about battery management from a perspective as we have at Metronics. And yeah, I think it was already good to have a short introduction from the partners, Amotech, EV Charger, and Advanced Mobility. Today, like Dennis already explained, it will be an interactive session. The agenda is as follows, that I will introduce myself briefly, the company Metronics. We will talk about the 12-volt battery management solutions, as well as the high voltage battery management solutions. And in the end, there will be a specific session for questions and contact details. But of course, like Dennis already explained, please raise your hand or type in any questions in the comments. We will try to answer them during the presentation. For me, it's a little harder because I cannot see them live, but with the help of the others, I'm sure that we will manage it and we will be able to answer your questions straight away, or at least as soon as possible, or either later on if it would not be possible during the presentation. Yeah, something about myself. My name is Anne-Jan Visser, mostly called AJ. I have an automotive background as an automotive engineer, and I'm working over 12 years with Maytronics. Started really as an engineer, meanwhile being a senior product manager, which means that I'm responsible for the technical side of the product, making sure that our customers are getting the right products as they requested them. Yeah, and due to the 12-year experience, yeah, I know quite a lot about batteries, 12-volt batteries, but also high-volt batteries. So we built up quite some experience over the years, and I'm happy to explain our vision on battery management. For those who don't know the company Maytronics, a brief introduction. Maytronics is a worldwide company with its headquarters located in Willowbrook in the United States. It's pretty close to Chicago, 30-minute drive from the main airport there. We have also other locations, like the headquarters for Europe, Middle East, and Africa is located in the Netherlands, in Houten. That's actually where I'm working from. We have offices in China, Japan, and even smaller sales offices in different countries. But because we are working with major players in the world, we need to have a so-called global footprint to be able to serve them. Also, when the programs are rolled out to the workshops. Our purpose, our company purpose is advancing battery management. So continuously looking for improvements, looking for better ways of battery management. And we have a vision and strategy that's about being experts in battery management. That's about technological innovation. We try to be as innovative as possible. Maytronics is sometimes even known as having a lot of patents, which we do have on all different kind of battery technology. We have a global footprint, as I explained already earlier. There are some product groups. So it's we have the battery diagnostic group. We have battery charging and maintenance, XEV, that's how we internally call the high voltage solutions, and information system and integrated solutions. These are all separate product groups which are focusing on different problems, different opportunities in the market. First, I want to highlight on the 12-volt battery management, because that's the part which is out for the longest period of time, since we have 12-volt batteries for ages already. Yeah, this is the part where we also where it all started for Maytronics, and I want to start there. Just as a short reminder, the 12-volt lead-acid battery, when did it really start? That was even back in 1886 when it was invented. Not exactly as in the picture, but soon after they start building more cells together, and it ended up being a 12-volt battery being a solution for many vehicles. Also, there are different types of 12-volt batteries. They are all lead-acid batteries, so the chemistry to store the power is lead-acid. But there are different types of these batteries, which are the SLI, the standard lead-acid battery. We have an enhanced flooded battery, which is commonly used in vehicles which are equipped with a start-stop system, AGM or AGM spiral batteries, which are conceptually more or less the same. The only thing is that from the outside, they are slightly different. And last but not least, we have batteries with gel. I don't want to dig in too deeply for now. It's just giving you a short overview that there are different flavors in lead acid batteries already. There is also a so-called battery life cycle. That means that the battery, it starts somewhere, usually at the manufacturing side, and then the life of the battery basically starts. And the thing with a battery is already that you know that a battery will, the life of the battery will end at a certain moment. That's just a given, because the nature of the battery is that it can supply power over an amount of time. But after producing it, you know the battery life will come to an end within a period of time. And the period of time is really depending on how much care, how much was the battery taken care of during its complete lifetime. And that is why we even have concepts, and we even have programs where we monitor the battery from the very first part. So from the factory, when it leaves the battery manufacturer towards, for example, where it would be built into a car, that is usually the car factory. But even if the car will be shipped, sometimes long waiting times are included there, where it's important to monitor if the battery stays in a good shape, if it's not discharged over time, if it arrives at a workshop for a new car, usually that is a car dealership where it will be sold from. Also there, depending on the location, sometimes dealerships works with lots where they just have vehicles which are there, which you can buy. That depends, of course, per region. Anyway, also there, maintenance and service of the battery is required. And the whole process, more or less, really starts when the vehicle has been sold to the first user, and afterwards, where the battery can be checked on a regular basis when the vehicles arrive for service or other types of maintenance, to make sure that we can extend the battery lifetime as much as possible. Again, at the start, we know that the life of the battery will end at a certain moment. The only thing what we can do is try to prevent an early breakdown and try to make that battery life as long as possible within our capabilities. One part is the change of the 12-volt battery. Basically, the 12-volt battery, the use of the 12-volt battery has been changed quite a while over time. If we look back like 30 years ago or even 40 years ago, the battery was there to store energy, basically to crank the vehicle when it was necessary, and afterwards the alternator would take over, charge up the battery, and that was more or less it. So one important parameter at the time was the crankability of the battery. That was a parameter which really was important. Other than that, not so much was requested from the battery other than being able to crank the vehicle if it was needed. Although, especially over the last 20-30 years, we have seen cars changing quite completely with all kind of systems, from infotainment systems, from all kind of safety systems, which are all making use of the same 12-volt battery, which also included that basically the use of the 12-volt battery has changed quite drastically over the years. Besides that, like 20 years ago, we did see the first cars in Europe with start-stop systems, which means that in some circumstances, the engine will be switched off. For example, if you are waiting for a traffic light, usually that has been done to reduce pollution and even to reduce or to increase the fuel consumption or reduce the fuel consumption from that car. However, that has an impact on the battery as well, because you understand if you're at the traffic light and your lights are on or the radio or something else, there is no way that the alternator can charge it and can supply that power. So the battery has to do that. That overall had quite a big impact on the battery lifetime, but also on the use of the battery, which changed basically the battery applications. Are there any questions at the moment, Dennis? I don't know if you have noticed any questions which we should answer now.
No, at the moment, no. Can just continue.
Okay, good. Yeah, I just like we said, if there are any questions, just ask them. So I will try to every 2, 3, 4 slides to have a short break moment and to ask for the questions, since I cannot see them myself that easily. Anyway, I will continue if there are not at the moment. Then the next question is, okay, but yeah, when should I diagnose the 12-volt battery? Like I explained, the ideal world would be that you monitor the battery over the complete lifetime. However, that depends when you have access to the battery. And even for a workshop, especially for an aftermarket workshop, you only have a specific phase in the battery lifetime where you are capable of doing the maintenance on that battery. And that is usually when the vehicle is with a customer and that customer comes to your workshop for all kind of maintenance, or in some areas you have PTI inspection, so periodically safety inspections like yearly or bi-yearly, where you have to go to get your car checked for like emissions or safety regulations. These could be opportunities to check the battery as well. We in Midtronics are always suggesting to take the battery maintenance to the regular checklist of a vehicle. So when a vehicle would come in, just check the battery as well. If you probably would check the tires or the oil level or the washer fluid or whatsoever, because if you don't do it, there is a risk that the battery was bad, but yeah, you didn't maybe notice it because the car did still start that morning. The reason maybe you could be asked is, okay, but if the car is still starting, why should I take care of the battery? The battery is maybe still good. True. However, what you want to prevent as well is a breakdown. And I have a next slide about that as well. But again, what we call like preventative maintenance within Midtronics is that every chance you have when the vehicle enters your workshop, perform a battery test. Why? It takes not so much time. It's usually just under 1 minute, depending a bit on which device you're using, but it's not a lot of time. And the outcome is usually that the battery is in a good state, even from a state of charge and from a state of health. I mean, the battery can be discharged, but still healthy, so it only needs charged. That is the second bullet point. Or the battery is unhealthy and needs to be replaced. If you don't check it, you don't know. So again, our message is always add the battery testing to the checklist and start testing today, because that has some benefits. And I will come back to that in the next slide. So
AJ, before you go to the next slide, we have a question from Matt. Matt, you can go ahead.
I'm Matt from Varta Batteries UK. the state of charge chart that you've got there, where you've got 11.8 volts and still 20% state of charge, I would probably, just as a point to highlight, I would dispute that just from the point of view of any battery that is below 11.8 volts is actually completely flat. So at that point, that is where we at Varta would say 11.8 volts is zero state of charge.
Yeah, true. I mean, these charge deviate for battery types and different batteries, but yeah, it's just an example that battery state of charge is decreasing when the battery voltage is decreasing as well, and that there is an alarming factor, and that basically below 12.5 you should start taking action by charging up the battery. That was the main
Yes.
message. And yes, we can debate about what is the lowest level, but even at 12 volt you are already at a critical level where charging is absolutely necessary. I think that's a joint message we share.
Yeah, perfect. I just wanted to just highlight that just from a point of view of just ensuring that we don't take the battery further than that, only because obviously damage has already occurred.
Yeah, no, I'm fully with you, and honestly, I don't know where this particular chart is coming from, but I'm happy to change that, and I see that for different batteries sometimes there are slight differences, but indeed usually 11.8, 11.7 is considered to be 0% state of charge.
Yeah, perfect. Thanks, Anna.
Okay, you're welcome. Okay, if there aren't,
You can continue.
Yep, I will continue. So basically, the next slide is about the benefits of preventative maintenance. What I explained in the previous slide is that preventative maintenance is important because the testing takes less time, but it also helps you to keep the battery life, to extend the battery life. So if you detect a battery low on charge, what we just discussed, the message is always charge up the battery because it will help you to extend the battery life and make your end customer more happy. Why? Because there is a decrease of breakdowns. And why also there can be an increase in trust in the workshop. Probably you would ask, okay, but how? Well, what we advise as a battery tester manufacturer is that if you test the battery, let the customer know. Even if the battery was in a good shape, let the customer know, hey customer, we've checked your battery. It is at the moment still in a good shape. If you do that, and in 1 or 2 years from them, the message is, hey customer, we checked your battery again, but now the battery is in a bad shape. That will increase the trust that you checked it also the last 2 times, but not that you only check it to sell a battery, but also really that you are willing to do really battery preventative maintenance and to make sure that the customer doesn't break down and the customer satisfaction in the end will go up. That is the whole goal of battery management, to increase battery life and to reduce battery breakdowns. For the workshop, again, build customer trust and satisfaction. I talked already about it. It can be seen as an add-on service to your customer, letting know, okay, customer, you were in for an oil change or for a tire repair whatsoever. Although we did an additional check for you, we checked your battery. In this case, the battery was fine. If you find again the battery being bad in the next time, it is much more likely that the customer will stay with you and maybe buy a battery from you. Instead, he will drive off. Maybe the battery will fail in 1 or 2 weeks after. And then you don't know who's going to sell that same battery to the customer. It can be you as a workshop, but it can be also somebody else. I also have some what we call breakdown statistics. Unfortunately, the picture is in German, but I think most of you would at least understand what the meaning of it is. In Germany, we have quite a large roadside assistance club. This is a club which, if you are stranded with your car, they can come out and help you to whatever problem you have. They will try to solve it, or worst case, they will tow your car to the nearest workshop you want to go to. Every year, they are publishing like what are the most problems we see when we arrive at a vehicle breakdown. And every single year, the starter battery is by far the highest percentage in that list. As you can see, this one is from 23. Even I think the statistics are from 22 when they published it in last year. 43% of all the breakdowns, 43% of all the time they got out to a breakdown, there was a problem with the 12-volt battery. And that has also to do with battery maintenance. I'm quite sure if every workshop, even also in Europe, in Germany, would do proper battery maintenance, that this value could drop to a lower value. And you would have less breakdowns. Breakdowns will cost money because somebody has to go out there, needs to repair the car. But also in this case, usually these clubs they having batteries with them. And in that case, if they arrive at a customer, it is very likely that the customer will say yes if they offer them to replace the battery, because they are there, they can do it in a proper way. And as a battery workshop, there's no opportunity in that case to replace the battery because they did it. Also, the second one I would like to highlight is the 10% on alternator starters. Many of our devices do have an alternator and starter check. Why is that? Well, if the battery is bad, sometimes that's for a reason. It can be just normal use. Sometimes it is abuse, which is done by the customer. But sometimes it's due to a defect in the alternator or due to a drain in the car. Therefore, it's always good to check the alternator system as well. Like I said, our tools usually have a way to do that as well, where we ask you to crank the car, to check the alternator output, to make sure that the breakdown was not due to a failure in the alternator. Because if you replace the battery, of course, the problem will be solved, but only maybe for 1 or 2 weeks. Because if the alternator is still weak, in a couple of weeks after, the breakdown will happen again. Then I will move to the next slide. We already discussed about the changing.
Sorry, AJ, before you discuss the slide, you have 2 questions.
Okay.
One from James Momani. He's asking, what maintenance do we need to do on maintenance-free batteries?
That's a good question. For us, maintenance-free batteries is always a little bit debatable. They are in a way maintenance-free. You cannot open them up. You cannot refill them. That's absolutely true. What we call maintenance is charging the battery. So testing it and if necessary, charging the battery. That is really what we as Midtronic see as battery maintenance. Because again, if you charge the battery properly, you can extend the battery lifetime.
Okay, thank you. We have another one from Dennis Wakaba. He's asking, could you clearly define proper battery maintenance that can prevent breakdown?
Yes. I think, sorry, I didn't totally get it, but I think it was more like the same question that how we could reduce breakdowns by battery maintenance. Is that correct?
So he's asking if you could clearly define the proper battery maintenance procedures that can prevent breakdown. So he wants like
Okay.
an in-depth definition.
Yeah, well, battery manufacturers, they usually have recommendations when you should start charging a battery, but also if using, I would say, almost any test device, it will tell you if the battery voltage drops below a certain number to start charging. And that is an important parameter that you do that as well. Again, that extends the battery lifetime, and we have projects ongoing in Europe where we clearly could identify that if the batteries are charged on a regular basis, that increases the battery lifetime. We've data that we could see the battery defects and battery replaces dropping if proper battery charging has been done prior to that.
Okay,
I hope
Dennis, I hope that clarifies. We have another question from Joseph. He has raised his hand. Joseph, go ahead. Joseph? Okay. Maybe Joseph, you can type your question in the chat box and we'll be able to attend to you. Okay, you can proceed.
Okay, yeah, and even if if Joseph is able to ask his question later on already, and yeah, we are very willing to answer it. Okay, let's continue with this slide. I already explained that the function of the battery is changed quite a bit over time. Like I explained, for quite a while, we had vehicles with only internal combustion engines, where the function of the battery mainly was to crank the engine and to be a power source for that reason. Medtronic developed a way of checking the battery health, and that was called the so-called conductance technology, where by measuring the battery, we were able to measure the internal resistance and calculate the conductance from there. And also with an internal calculation, we could even show the amount of cranking amps which were left in the battery. That was for just vehicles with an internal combustion engine more or less enough, because that was the main function of the battery. However, when, like I explained, 20, 30 years ago, vehicles changed. We got vehicles with a lot of consumers. We got vehicles with start-stop systems. We got the first hybrid vehicles, where the battery sometimes is even not used to crank the engine anymore, like in a lot of hybrids. And if it was with a start-stop system, the battery is used in a different way. Yes, it is still cranking the battery, but it's also supplying power while waiting at a traffic light. And that was basically what I explained. In that case, the cranking of the battery can be still important, but there is also a second parameter, which is the so-called reserve capacity. So every battery has a label on it, which usually showed the called cranking amps. So that's the cranking capacity of the battery, which is a rather high number. And it shows it the capacity in amp hours, which is usually a lower number. That capacity became more and more important for these batteries because they needed to supply power when the engine was not running, or even when the battery was not used to crank the vehicle in hybrid applications, but just as a power source for a lot of systems which are on board. The next one are the fully electric vehicles. As you might know, and otherwise you will know it now, that a lot of EV cars, besides the big high volt battery, they still have a 12-volt lead acid battery. And these batteries have a function as well. Again, not for cranking anymore, because there's nothing to crank left. But this battery has also a safety function where if there is a problem with the high volt battery, the 12 volt battery should step up, or being used in that case as a backup. And therefore, it's important to make sure that also in EVs, the battery has a sufficient capacity. And based on that, Maytronics developed a new technology, which is called SPC diagnostics, where we do even a more in-depth check on the battery capacity to make sure that even for EV vehicles, the battery is still good to go, and there is a safe backup in case something would go wrong with the high voltage supply. And this is the last slide about the 12 volt. EV maintenance is changing. Also in Kenya, I noticed that there are coming EVs to the market. What we noticed is that the maintenance is changing, because like engine oil, spark plugs, these kind of things are no longer existing. So the maintenance of EVs is focusing on different topics, and usually a little bit less to take care of. But I think the importance of the 12 volt auxiliary battery is important, and can be even more important since there is a safety aspect related to that. And that's why we keep telling everybody, hey, there is still a 12 volt battery on that EV, and it even has an important function. So please make sure that you are checking it and using the right technology to do so. Okay, this was the first part about the 12 volt battery. I'm now changing over to the high volt battery management. If there are not any questions, I will directly move on. Just to make sure that we are all speaking the same language, some terminology which we are familiar using in Maytronics, and I want to make sure that everybody is aware of it. Usually a cell is just a single cell which is used in a high volt battery pack. There can be hundreds of cells in a battery pack. These cells are indicated in the picture like one green battery indicator. A module is usually a combination of multiple cells, and usually a module is the smallest serviceable portion of a pack, because usually it's not possible to open up modules and replace single cells of these high volt pack. Then as a general, a pack usually consists of multiple modules. It depends, it can be 5 to 10 or even more. That completely depends on the pack layout. And these modules are connected to each other by bus bars to make sure that the pack receives its final voltage and capacity by connecting the modules in a series and or parallel configuration. Okay, the next one, this is more or less the same as we discussed for the 12 volt battery. Also, the EV battery has a life cycle. And again, in every single step, there are actions, there are possibilities to check the battery and to do different levels of service. Of course, in the beginning, that's not something a workshop is connected to. But as soon as the car arrives at a workshop, at a dealer, and the first owner starts driving with it, there is an opportunity to perform all kinds of checks and services on these vehicles, which is important. And again, it goes all the way to refurbishment, to recycling. these are projects we are seeing quite a lot now, also in the Netherlands, that with used automotive packs, some power solutions are built to power specific off-grid workshops or off-grid installations, and to help them to overcome power problems. So basically, the whole battery life cycle has opportunities to perform service. But I'm well aware that for real workshops, that is limited to the time where the battery has been attached to the car, and it's basically a driving vehicle. What kind of services are possible on an EV pack? Well, there are various services possible, like verification, in-vehicle state of charge, out-of-vehicle state of charge, safety checks on the pack, module balancing. They're all named on this page, and I want to highlight the ones which are with the green, the highlighted green ones. I want to dig in a little bit more to get clear. Okay, what kind of services can we do on these high volt packs? The first use case is high voltage diagnostics. What is it? Well, the vehicles are driving around, and there may be circumstances where the car was in an accident, or even at a regular basis, you want to make sure that the pack is still safe and there are no shortcuts, there is no leakage. So there are tools in development, also by us, by Minntronix, which you can attach to the normal charging port, and with some simple actions, you will be able to read out some measurements about the insulation of the pack, if it's still okay, if there are any errors with the pack. And again, especially if a car would have run into an accident, that could help you to make sure that the pack is still in a safe state, and you could start working in towing away the car or moving it to a different location. This is also something which in some countries is considered to be part of like a periodically inspection, a PTI inspection, to make sure that also for EV cars, the high volt battery pack is in a good shape. The next use case is depowering the pack. And why should you do that? That depends. Usually, it can be done if the pack needs to be sent to a specific location. There is no official regulation at the moment, but usually 30% state of charge is be considered as a pack below 30% is be considered as the best state of charge to allow somebody to ship it. So that could be a reason to discharge the pack. Discharging the pack could also be a reason when you reach the end of life of the pack, or you really need to dismantle the pack. So we have different dismantling companies which are interested to have such a pack depower device to make sure that before they start completely depowering the pack to and work on it to make sure that all the energy is drained from it. On the other hand, the other use case is charging the pack. So basically, charging and discharging are usually combined in one device. And why should you use that? Well, for example, these packs are also stored somewhere. And during storage, although it is low, there is an internal self-discharge, and they need to be maintained. And sometimes, due to regulations, they also need to be checked on a regular basis. The next use case is basically what we call hybrid rescue charge. We shortly touched based on this topic on the 12-volt battery side, where we noticed that a lot of hybrid cars do not use the 12-volt battery to crank the engine, which is still there in a hybrid. However, the EV pack is being used for that. Although the problem will raise when that EV pack, that hybrid pack, is running below a certain threshold where it's not able to crank the engine anymore. In that case, you would be stuck in a situation where the car basically cannot crank the engine and cannot recover from the low hybrid battery. Maytronics has developed solutions there to basically jumpstart the HV pack and to allow the vehicle to crank the engine, and then afterwards the vehicle will take over and charge the pack up again, so it can be still used and you don't need to replace a complete pack since it was only discharged. And then the last but not least for EV maintenance is what we call module balancing. As I explained, high volt packages are usually divided into modules, and usually that is the lowest level of service which can be done in a workshop or in an EV center. If we don't, if you replace the module for another one, usually the new module is not on the same state of charge level than the other modules which are still existing in the pack. The problem is that if the deviation is too big, the pack software, the BCU, will not accept the new module, and there will be a problem because the car won't drive because there is an error in the battery pack. Therefore, module balancing is important to make sure that the new module is on the same level as the other modules which are in the pack. So a target voltage should be defined, and the device should charge up or even discharge the module to that same level. Another function could be that the module which is taken out of the pack is discharged to a more safe level, for example, to 30% state of charge, which makes shipping it over easier if it needs to go back, for example, to the importer or to some other location. I think there's a question. I see somebody raised his hand. So Joseph, if you have.
Just to go through, finish the slides, and then we'll take the questions.
Yeah, well, I was. So you want to finish the complete presentation, or only the slide?
Yes, kindly do finish the presentation, and then we'll take the questions.
It's almost done. The only thing left is basically the range of products Maytronics is offering. So for 12-volt solutions, and I don't want to spend too much time on it. We can explain that. They are also on our website. But just to give you an overview, we have different platforms to either test and or charge the 12-volt battery. And we have different platforms to charge, discharge, rescue charge, or module balance the EV pack. And we also are working on a safety check on the full pack as well when it's built into the car. That was basically the presentation. So, any questions?
Yes, there are questions. So the other question from Joseph is asking, how long should a good battery be able to crank after a car is parked? Example, BMW 12 volts 90 Ah.
Sorry, how long should the battery?
Should a good battery be able to crank after a car is parked? Maybe you can check the charts. You can be able to see the question.
Excuse me.
I think from Joseph.
Yeah, that's a good and an interesting question. That really depends, Joseph, on, let's say, what drain is on the car. Usually, like BMWs with, well, they can have problems after 3-4 weeks. Why? There are a lot of systems. Also, they are still active sometimes when the car is parked. Unfortunately, I cannot give you just a fixed number. Again, that really depends on what is built into the car. How well is the well, it's a good battery, so I would assume at least a few weeks. But usually there the problem starts where maybe the battery has been replaced, but still there is a drain which is draining the battery, like even with 50 milliamps or 100 milliamps. If you count that over a day, you can drain the battery, even that large battery, you can drain it in a few weeks to a level where it would not be able to crank the car anymore. So I would always recommend, if there are any problems, to check if there is a drain in the car which causes the battery to discharge over time.
Thank you, AJ. We have the next question from Magu. Kindly explain what constitutes a cell.
Yeah, what constitutes a cell? Yeah, basically in an EV vehicle, the battery pack is built from cells, and there is a wide variety of cells. Usually it is lithium ion, but if you probably might be aware, there are all kind of new technologies with lithium, with different chemistries. But the cell is basically like in a 12-volt battery, consisting of an anode and a cathode, and therefore able to store and supply energy, to take energy and to supply energy, and also to store energy. That is, I think, in a nutshell, yeah, what I can explain about a cell.
Thank you. We have another question from Matt King. He's asking, does discharging of the high voltage batteries need to be carried out in a balanced way? I know sometimes in charging this is the case. I'm not sure if the same is needed for discharging safely.
Yes, and that's a good question. So usually our tools are connected to the battery control unit while charging or discharging, monitoring, let's say, the individual cell voltages to make sure that while charging and discharging, the battery is still in a good shape. It's actually a very good question, because the battery is usually not in the car at that moment, so the coolant system is not working. So you need to make sure that you're not overcharging and not overheating the pack. And like I said, with a monitoring system, which we have in our tools, we are preventing from running into problems there.
Okay, I hope that clarifies much. We have another question from Ian. He's asking, he has had an experience with a diagnostic tool which allow one to check the SOC of different modules or cells in a battery pack. So his question is, in the event of a faulty cell is found outside the voltage parameters, is there any way through the software or hardware of shunting the module to effectively bypass it?
Sometimes yes. I mean, most of these packs or modules do have balancing. However, that is on a very small level, and we also deviating between active and passive module balancing. The problem is, if the deviation in cell voltages or module voltages is too large, the control system would not allow these differences and will automatically generate an error, and the pack or module is not used. There are ways to charge or discharge single cells. However, usually if you have a complete module and it's sealed, it's pretty hard to get onto single cells to charge or discharge them. And usually there's a reason if there is a deviation. Usually there is like an increased internal resistance or something else. What we have noticed that sometimes if you do that, so you balance single cells, it can work out, but sometimes it won't. And after 2 months, for example, the deviation is there again, and yeah, you're back to the problem.
Okay. Alex is asking, please clarify if there is one HV equipment, high voltage equipment, to measure state of charge, of health, and depth of discharge.
Different companies are working on that. State of charge, yes, that's I wouldn't say the easiest one, but that's something which is easy. State of health, a lot of companies are working on that. At the moment, it's usually quite a time-consuming process because most suppliers in the market are requiring even a partial drive or discharge to do that in a proper way. Depth of discharge, that is hard because then you need to read out basically, sometimes that's possible, but you need to read out the history from the car to know, okay, how many times did it happen? But yes, there is some equipment, but the question, at least in Europe, is really also, okay, but what is state of health from a battery pack? Is that really the capacity? Is that the real capacity or the capacity which is used by the car? Because the technology is relatively new, not everything is really solid at the moment, and yeah, still something needs to be figured out. But there are devices which start to do that, and I know that there will be regulations, or the European Union is working on the regulations to set some limits for state of health of EV packs.
Okay, thank you, AJ. I think we are out of time, but we'll just 2 more questions. And if you have any other questions, you can share them through the contact that we'll. So we'll just take 2 more in the interest of time, and then we'll close the Q&A. So we have one from Singh. He's asking, an EV was towed to a charge station at Tesla Model 3. After several attempts to charge it with a 22 kilowatt charge module, the car did not respond to charging, even though the 12-volt battery was jump-started. What could be the cause?
Yeah, that's pretty hard on a distance, but yeah, there could be various reasons. It could even be in the high volt pack that there would be an error. It could be even in the charging station or in the at the car side or even at the location side. I would also advise to use a different, because the 22 kilowatt could work, but sometimes yeah, use a different one to see if that makes a difference. Yeah, several reasons, and unfortunately, yeah, it is pretty hard for me on the distance to explain or to find out what would be the exact reason. But like I said, I would try various chargers, but also check if the in-vehicle charger, so usually that's behind the charge port on the vehicle, there is some software and hardware which makes sure that the charge will even be conducted from AC to DC if needed. There could be a failure in that hardware as well.
Okay, thank you. The final question is from Brayton. He's asking, vehicle with 2 HV battery packs connected in parallel, when one pack becomes faulty, can you continue using the other pack?
No, usually in parallel not, because that will influence heavily the capacity, and when one pack is bad, usually the voltage is of that pack is dropping rapidly, and it will have a big influence on the other section as well. So yeah, you might be able to do it, but I think it will decrease the lifetime of the other pack drastically as well.
Okay, thank you. I think because of time, we'll close the Q&A session. If you have any other questions, you can contact us through the contact details on your screen, and we'll be able to respond to you as soon as possible. We have also sent a feedback form to your emails, so you can just give us feedback, because it's through the form that we are able to tailor future webinars according to your needs. So if you can find time to fill the feedback form, we'll appreciate. So thank you, everyone. Thank you for the speakers. Thank you, AJ. And thank you even for those who have asked questions, and even to everyone for just making time and attending the webinar. This is the first of many webinars to come, because as you know, the EV landscape in Kenya is changing and really growing. So there'll be more need for these webinars in the future. So we have plans for more webinars, and we would, I'd like to reiterate, the feedback form that you're gonna send is the one that now will help us to tailor the future webinars according to your needs. We'll also send a recording of this presentation and also the webinar itself to your email, so that you can refer to it in the future. Otherwise, that's all from us, and thank you so much for joining us today. Thank you. AJ, any questions?
Yeah, again, thank you very much for inviting us and giving us the opportunity to explain. Thanks all for joining. And again, if you have any questions, feel free to reach out to Amotech, and they will reach out to us if necessary.
All right. Thank you, and have a good day, everyone. Bye-bye.
Thank you.